All right, everyone. Sunny Madra and myself are going to have a quick conversation about Shopify and Groq. So welcome to Sunny.
Hey, thanks. Thanks for having me.
And hello to everyone on the live stream. We will also be taking questions after. So maybe people don't know, actually, Sunny was my old boss. 2009.
Yeah.
2013.
Now it's the other way around. You're my boss.
Well, I mean, we're a customer, right?
Yeah, you guys are. Yeah.
We're a customer, so yes, in theory, Groq does work for Shopify now. But let's talk a little bit about the genesis of Groq. So for those who don't know, maybe just explain what Groq is and actually how it came to be.
Yeah. So the company was founded, and our current CEO is a gentleman by the name of Jonathan Ross, and he has a really interesting history. He was working in Google very early on. And he had listened to a talk by Jeff Dean, who's the head computer scientist of Google. And Jeff had a good news, bad news talk. The good news, hey, we've solved automatic speech recognition. Bad news, there's not enough compute in the world to actually, implement it. And so in those days, Google had this, 20% program where you could take 20% of your time and do whatever you wanted. And Jonathan, being a software guy, working in like optimization or something like that, decided to basically learn how to build a chip in an FPGA and built the first version of the TPU as a project to prove that you could, implement a new type of architecture to take on machine learning problems. And so that led to the creation of the TPU, which Jonathan is a founder of. And then Jonathan really thought that the rest of the world should have access to these technologies and left to kind of create a different architecture, which is the Groq LPU architecture, which is what we have now.
Cool. And the difference between like TPU, LPU, and GPU is that GPUs can be used for training, right? The training of the LLMs that we see today, and inference. But then LPUs, which is learning processor unit, and tensor processing unit, those are just for inference.
Yeah, I mean, the TPUs can be used for training as well. I would say, basically a slightly different way to think about it is Groq is a SRAM-only solution. So it's all on-chip memory versus TPUs and LPUs have external memory, which refer to as HBM, high bandwidth memory. And because of that, Groq has a really, really unique ability to produce fast tokens and really low cost tokens. There's a lot of energy that's used when you have external memory, and external memory can be quite expensive.
Okay, interesting. Have folks tried Groq Cloud, or Groq? Oh, you have.
All right.
One of the most interesting things, I think, when I first got introduced to Groq was the latency. Like you use it, and the latency is so striking. Like it's not slightly faster.
Yeah.
It's like 10 times faster, and it feels like pages. Like, when you use ChatGPT or use Perplexity, and you kind of see the text flowing down slightly faster than reading speed.
Yeah.
Groq seems like almost pages of text fly across your screen.
Yeah. Yeah. And I would say, there's a couple things when, we started to really push that out. A lot of people would say, well, why does it need to be faster than reading speed? And if you have a chance, like, think about a Google page load, like a search load, or even for what you guys do. You guys measure the impact of milliseconds and what that means to conversion. And so if you took the rest of the internet and made it load slow, you'd see a huge impact on conversion and things like that. So going faster is one thing. The other thing is, as we move towards reasoning models, there's a lot more tokens being processed behind the scenes. So the faster you can process tokens that may even not be displayed to the end user will result in better results that are happening, because a lot more reasoning is happening on your problem.
Cool. One thing that's interesting about Groq too is not just the design. So obviously there's new designs coming out, right? You guys are in version 3 of the chip, or?
No, version 1.
Version 1?
Yeah,
okay,
yeah.
So tell us about what's happening in chip design to get to version 2 and 3.
Yeah. So, what's interesting is, and this is, a lot of debate today about, GPUs, which are general purpose, versus, LPUs and ASICs, accelerators like ours. But, you have to think about, from an architecture standpoint, our chip was designed before, the attention paper was even written. And so the fundamentals of how we, process matrices, right, is in the core of what we're doing. So our current chip is designed, between 2016 and 2019, taped out. And then our next generation chips will take advantage of going to today we're on a 14 nanometer technology. The next generation chips will go to more, modern process technologies like 4 nanometer and beyond.
One interesting thing in the geopolitical sense is that's made in the USA.
It is, yeah.
Right. So are you guys the only? I think it's just Intel and you, or like who manufactures chips in North America?
Yeah, I think from an accelerators, like AI accelerators, we're the only one.
You're the only one. Okay.
Yeah, but Intel has huge fab facilities for general purpose compute, and everyone is trying to do that now, right? With TSMC is trying to open a fab. Samsung is going to be opening a fab in Texas as well that you guys can read about. We have a good relationship with them, but that's something that really Jonathan focused on early on, is basically building something that takes advantage of an American supply chain. And, us doing that now, and like you said, in the current environment, has been really beneficial for us.
Yeah, especially like you've got like a North American homegrown, and you're continuing, like your next generation chip will also be.
Yeah, we're going to take advantage of the whole American supply chain, going forward as much as we can.
Cool. And then you recently also announced some stuff happening in Canada.
Yeah, we have a couple of different initiatives. We, a couple months ago, we announced something with Bell, which is we're opening a couple of data centers together with them to power, workloads for enterprises in Canada, but also for, government workloads. And so we're excited. And that data center is really unique. That data center actually is cooled by the Thompson River. And then the heating that happens to the water there is used to heat the surrounding buildings at Thompson River University. So that's really exciting. It's like a whole story there. And, we now have, I think, I don't know how much we talk about this. We have 4 data centers in Canada. So
I didn't even know that.
Yeah, Canada's a really unique spot for that. Really unique. Close latency to the U.S., great access to power, a lot of renewable power as well. So it's very exciting.
Yeah, it's interesting. It could be like a natural resource for Canada to export to other countries.
Yeah, I mean, I have a long background with Canadian initially, and so I would say, Canada should be putting their hand up to build like the next Stargate. Right. We see them being built around the world in different places, but Canada seems like a really good place for that to happen next.
Yeah. Let's talk about that, because there's a couple of things that you're involved in I think would be interesting for the team to hear about. So one was, I posted my announcement here that you were at that tech dinner.
Yeah.
Right. So for those of you who didn't see, like, and regardless of your politics, right, having dinner with the president of the United States and having Bill Gates there and Mark Zuckerberg and Sam Altman and Lisa Su and Tim Cook and I can't. There's so many more people there. So like, tell us about that, and like, what does it mean for at the government level to be having those technical conversations?
Yeah, I think the most important thing there is, it's really interesting. Bill Gurley has this talk from the the All In Summit a couple of years ago, and the title of the talk's like 2,650 or something. And really, that's the distance between Silicon Valley and Washington, D.C. And his whole talk is about, for 30 plus years, Silicon Valley has thrived because it was so far away from Washington, D.C. And in the last couple of years, we've seen that flip around, where Washington, D.C., or even beyond that, governments are getting much more involved with technology. And so, with that comes some benefits, maybe some regulation rules that, make things more fair. But on the other side, it slows things down. And I think what you see now with the current administration, there's an open dialogue, right, in terms of what's happening. And that's important from, a couple standpoints. One, it's important for those companies to know that they have support of the government. They're not in a kind of a adversarial stance with each other. Two, there's all these things that happen around the world where other countries are putting taxes. I think even Canada has tried to put a digital services tax on companies, and that may or may not be the best thing for for those companies. And so there needs to be a dialogue there and how to manage that as well. And then lastly, I think it's well understood that as we move into this era of AI, there is huge implications around energy, being able to deploy energy quickly, around how we treat models, how we treat the data that goes into models. And so the AI action plan that also came out a couple months ago, the president was heavily involved in that. And there's a couple key things that he highlighted there. One, the president said that any energy related project that's for data centers for AI can get fast tracked through the government. It's really important. Two, he also stated that there's he created a path for content that's being used to train these models to not be subject to certain types of copyright laws. And then So these things really help, the U.S. companies that are are winning and want to continue to win in AI do that.
Cool. And I think what's interesting about Canada is we're trying to do the same thing, which is like Ottawa is where Shopify started, close to the government. And now the government is seeing that they could be more efficient using AI tools, even like locally grown Canadian companies with those AI tools in order to make sure that we're getting the best services. Like no one likes going to renew their driver's license or their passport. It's a pain in the ass. Are there things you can do that are more efficient?
Yeah, I mean, and AI is unique. My second company we built and sold to Ford, right? And Farhan was an investor too, so great. But one of the things I learned in that was, the history of automotive. It's really tied into the Industrial Revolution, but also, from a national security and independence standpoint, there's a reason if you look at where auto companies exist, they exist in countries that wanted to basically be, comfortable that they, from a military perspective, had the understanding and ability to be industrially, relevant. And so that same thing's happening in AI. And I think for Canada, it's important to basically be at the frontier there as well. Canada was important in the industrial age and digital age. And I think as we go into AI, that should be a really big initiative for the country.
Yeah, I remember reading a thing that said like, if your mouse breaks, like who actually could open the mouse and like fix it? Like,
Yeah.
right? Because we don't have that competence anymore,
Yeah.
right, given the components. Let's go back to the technology of Groq. So how does it work? Like a new model comes out. So OpenAI releases a new model, or Gemini, or the other Groq with a K, or open source model. What do you have to do? Because actually one of the debates I've had, and actually I had this with Mikhail, was when I told him I was an investor in Groq, he was like, oh, this is never going to work. I was like, okay, why? And he said, well, the work that they have to do to get the model to every new model, right? Any new model comes out, the work they have to do to convert it to run on the LPU and then to be served efficiently is tremendous. That was his, and he's like, so there's no way. So when he goes, you'll see when Llama 4 comes out from Meta, you'll see how long it takes for Llama 4 to be introduced to when Groq can have their model running on Llama. So tell us about how it works and how fast that was.
Well, both for Llama 4 and GPT OSS, we were launch partners.
Right. So maybe, so when it was announced, you were on the same day.
Yeah, exactly. If we simplify, so we have a compiler, and that compiler runs on PyTorch, right? Yep. So the work, and it's sort of interesting, right? I'm going to take one step back just to kind of walk through. At the end of the day, all the frontier research labs are working with NVIDIA first and foremost to build these models because they're training on NVIDIA hardware, right?
That's right. So that just to make sure, so Meta's work, so even though they're training their models on NVIDIA chips, you're saying they have a close relationship with NVIDIA all throughout the process.
And the reason is NVIDIA engineers are sitting very closely with them to, basically understand what the future hardware looks like in terms of, where memory bandwidth is going, or, what specific accelerations they're putting in the hardware, right?
Yeah, but that's interesting. So during the runs.
Yeah, and for the future, right? And so, and that's really good for NVIDIA. It's part of their moat, right? And then those things are exposed through CUDA kernels, right? And so, and really what I say is on the training side, I see it very difficult for anybody to ever displace NVIDIA because they're so tightly coupled, and the training runs are so expensive, and they become so customized to, if you really look at model size, like look at GPT OSS 120, right? That size of that model isn't randomly decided. It's also very much in tune to like the size of the latest, NVIDIA H200 or something like that. That's the amount that can fit in like a single GPU without having to go to multiple GPUs, right? And then obviously things change for bigger models. So there's a tight coupling there. Now, you take a step back for inference, right? You actually don't need that tight coupling because once you can get past the CUDA specifics, which are mostly done for training, not so much in the inference phase. And that's what we do. And so we have a compiler, and the work that generally has to happen on our side is if there's new mechanisms that they're exploiting in, like, say, the attention, whether it was like, MLA or sliding window, these are the kind of things, those are the implementations we have to do. But those are the same thing AMD would have to do. And they're the same thing that the other accelerators have to do. And I think...
What's the timing? Because it wasn't that the other teams don't have to do it. It's more like, well, it'll take months.
No, I mean, what's even better now is if you're working with the labs early on enough, which we are, we can be there for launch, as we've shown. Beyond that now, We use AI ourselves, right? And using,
Cursor.
exactly, right? And we use that to help implement those things. And so that thing, which I would say it's mostly weeks, not months, but weeks is becoming days and hours for us. So it's really that time frame is collapsing.
Okay, that's super interesting because then I get the notion of like, so every new model, so a Quen model comes out, you're not working, I don't know if you work with Chinese companies.
We do.
You do? Okay, so
we
let's say there's a model that you've never seen before, it comes out, becomes popular, you can take it from 0 to like running on Groq Cloud in days.
The longest I've ever seen is like a few weeks. And that's because there was like a real heavy change in implementation. But usually it's hours, right? Even if we haven't seen it before.
Amazing. Okay, so then that completely changes the economics of that model, right?
And just so you know, models go through these two kind of evolutions, right? There is weight updates, which is instantaneous for us. That's just a recompilation. So that takes 0. And then there's like architectural changes. And model architectural changes don't happen all that often.
Okay, that's interesting.
Yeah.
And in terms of what models do you not have? Like you don't have OpenAI.
Well, we have GPT-OSS.
Oh, you have GPT-OSS.
Yeah,
okay,
both the 20 and the 120. Yeah.
Right, but then so it's open source versus closed. So
we have some closed source models. We actually run some closed source models from Cohere for some customers. Yeah.
Okay, so there's some models that you have, not all of them. It seems like basically from a cloud perspective, I could go to AWS Bedrock. There's some set of closed and open source models. I can go to Google's closed and source. You guys are similar. You'll have some closed, some open.
Yeah, and what we try to do, for customers, especially someone like Shopify, we'll run anything for you guys. If you guys came to us and say, hey, run this for us, we would do that, right? What you see in our cloud is we're trying to provide enough of a footprint that is inclusive of models for different use cases. And so we try to cover off, for us in terms of coding, we like DeepSeek v3 and Kimi K2. So we have that there to cover off the coding use cases, right? And then we have, other like reasoning models, like DeepSeek R1 for that. So we try to cover off the breadth of things so that when developers are building things, they can kind of pick and choose the pieces because it's mostly an ensemble today. It's rare that you're using one model. And then beyond that, we're actually starting to stitch things together. So we have some new offerings. We have this offering called Compound, right? And what that does is that's a model that has access to tools built in. And it uses different models to call the tools. And so that has access to search, has access to Wolfram Alpha. And we've done all that work underneath. And we stitch it all together so it's faster for the end user.
So even like a model that calls multiple models, you can have that flow set up all in Groq.
It's already in there for us, right? So that simplifies it from the end developer perspective. So you're not having to go do the integration and all those things.
Okay, and then in terms of
and one more thing there. We just did this remote MCP server.
Okay.
Yeah, so what that does is basically if you're doing that, you can basically have the model speak to any of the MCP servers that are out there. It's really, we just launched that this week. I was really excited.
Oh, nice. Okay. So that's interesting. But there are a set, so you kind of have to go to, like, there is a bunch of closed models you wouldn't have, the open models you have, even the routing you have. Okay, and I'm assuming you're talking to those folks to try to see if you can get their more and more closed models. Like
we're and either so that we can launch them or we can help in their inference stacks as well.
Right. Okay, and then you mentioned everyone's training on GPUs except Google, right?
Oh no, Google is training on GPUs too.
Oh, they are. Yeah, I thought you said we can train on TPUs.
They can, but like I said, I think there's distinct advantages that NVIDIA, like there's a natural tie-in to researchers and NVIDIA that there's an extra step that people have to take to basically train on something that's other than NVIDIA. And then the real question is, there's advantages by working closely with NVIDIA in terms of the speed of the training clusters or the math functions you may have access to that they have in hardware.
And the talent that already knows NVIDIA and the CUDA stack.
Yeah.
Okay, so then if you're AMD or Intel maybe one day wants to do GPU program, the best advice for them is to just adopt CUDA or...
Yeah, I mean, like if I was anybody other than NVIDIA, you'd have to get like a frontier lab. Either if I was AMD or Intel, I would have invested. How I think you guys saw this announcement. It was just this week, right? Where NVIDIA invests like $100 billion
OpenAI
over like 20% of the company.
Yep.
AMD should do that with like one of the other. The next
and then move them onto their stack
and basically and take that and forward deploy their engineers and kind of create a whole path. That's what I would do if I was them.
Okay, interesting. Let's keep going down the path of like we talked about North American, and I know you spend a lot of time in the Middle East.
Yeah.
So let's talk about what does that mean for Groq and AI. So what's happening? We saw like Sam Altman was in the Middle East. Like what's happening there, and why is it so important for us to like I guess export North American technology in that direction?
Well, there's kind of two things there. I think first is the Middle East has been and will continue to be the source of much of the world's energy, right? Canada's up there too. That's why it's kind of unique. And so because they've been the source of the world's energy, they feel as though, and I think they're right, that they're uniquely positioned for AI, right? The kind of couple things you need to basically be really good at AI beyond the chips is you need access to a lot of power, which they can have through their own initiatives, and two, you want to basically have good access to people. So the advantage that they have is if you draw like a say a 1,500 or maybe a 2,000 kilometer circle from the center of the Middle East somewhere. Let's just pick Riyadh or something. You cover something like 2.5 billion people because you get into Africa, you get into India, you get into Southern Europe and Middle East itself. And so what they're thinking is they can serve all inference that's going to happen, all accelerated compute from that location. And so
not training, just focused on inference.
Yeah, just focus. I mean, training as well. Like there's a big Stargate being built in UAE, and that's the other side of it. But I think what will happen is, and it's already happened, the ratio of inference to training, it may be something like 5-1 today. It's going to be something like 5 billion to 1. How often do you compile a program versus how often do you run it? And so with that, what you'll start to see is, more of the serving for that region, if they do things correctly, can come from there. And especially places like Africa and India who want, who they want themselves, and we want them to have low cost access to intelligence to serve it from there with low cost power it's a real good match.
Yeah, this really reminds me of the the cell phone revolution in that third world where they skipped landlines.
Yeah.
Right. So maybe the idea is that they can, in many cases, skip most of the training and just adopt the inference directly and say, hey, we've got frontier models, they're already built, just have inference, and now you can have access to this in the developing world.
Yeah, in many ways, even skip the cloud, like the traditional cloud. Like
and just go straight to like GPU cloud.
Exactly. Skip the general purpose cloud era and go right to accelerated compute.
That's interesting. I mean, they still need to have CPUs to like run the program, like run their application stack.
Yeah, but the ratio will be a lot smaller, right?
Yeah.
And look, like you and I talk about it, we built apps for a long time. And so think about just 2 or 3 years ago, if everyone's having lunch here, if you wanted to build a calorie counting app, say 3 years ago, what would you have to do? You'd get a couple of machine learning folks to help you build a model. That one model would be to detect what is the food. Another one would be to size the food. And then you'd basically create a pipeline so you could update that all the time using some AWS or GCP service. And then you'd go get a third-party database that tells you, once you know what the food is and the size of it, how many calories is that, then you'd have all this other application logic to stick all that together, and you'd be doing that all the time. Today, you can take a picture and send it to your favorite model and say, return in JSON, what is this? And you can do it right now with your meal, and it'll do it accurately. So most of that work is happening accelerated. The final bits may happen in general purpose, but the heavy lifting is happening in accelerated compute.
Yeah, that's interesting. I'm just thinking about my own infrastructure now.
Yeah.
Okay, cool. You basically just build hot dog, not hot dog, right? Like you can easy to build now and just using those models. Let's talk about talent. You talked about the talent in the Middle East. I mean, obviously we're big fans. How many people are here are an intern at Shopify?
Oh, all right.
Lots of interns.
When I was walking in, it's like really young. I like that.
Yeah.
Energy.
We have lots of interns here. You guys are now hiring interns as well. Talk about that and like what's your strategy for hiring people? What kind of people are you looking for?
Yeah. Well, I think there's the following shifts that are happening more broadly. I'll talk about it from a Silicon Valley perspective, but I think it applies everywhere. Silicon Valley, when it started, which predates even both of us, even though we're old now, was really a place for young people, right? And that's what it was done. And I would say definitely through, the 80s and 90s, driven by a lot of, young people combined with the folks that had the experience that they could transfer down to young people. And then we went through this like kind of odd time of almost say 25 years of say 2000 through to 2025 or maybe 2024, right? Where the middle got bloated. And that became, it became full of management and all kinds of other people. And now we're in this time where the people that will make the most impact, that will have the best jobs, are the youngest folks. Because one, you guys are hungrier. Two, you're what I'd say AI natives, right? And so I generally feel as though the growth of a company will be highly correlated to how many young people they have, because those are the people that have access to technology. And if we rewind back to our own careers, like there was a time and place when I was at Cisco early on in my career where you couldn't use search. It was like they had it like blocked. And I don't know.
You couldn't use Google, or
Yeah,
like,
yeah, because they had it blocked, and so and you think to yourself like, how can you do this?
the banks had that. Yeah.
Yeah, exactly, right. And so, and in many ways, like AI is not quite that bad, but people are still trying to figure it out. But the folks that are AI native can do things that even the most experienced engineers can't do, right? Because they're willing to do it. And experienced engineers go through this bias a little bit of like, no, like I know how to do that, I'm going to do it. And so, we've had models distilled by interns. We've had to hire a couple people where their parents had to sign their offer letters because they not as the interns, like as full times, right?
Yeah.
And because if you're under 18, I guess that's what you have to do. And so I really think the young folks that are coming in that are AI natives, you guys are going to be, sort of the leaders very, very quickly.
Yeah, there was this funny thing from, I think there's many, like, it was like some old McKinsey study or something that said you should never have a meeting with you need to have at least 30% of the people under 30 or something.
Yeah.
Like,
Oh, that's smart.
Yeah, it was like from like 20, 30 years ago, because like you're gonna miss the next shift.
Yeah.
So in terms of like Groq, like how many people are there? How many interns do you hire per year?
Yeah, we are. I don't have the exact numbers, so don't quote me on this or anything. But like, we're about 400 people total, and at any given time, there's probably 50 to 100 interns. But we're really upping that now.
Yeah,
I think we've had tremendous success in the last couple of years with interns, and there's just a much better correlation now, in the large language model era, frontier model era, generative AI era, for interns to do more for us, right? And so I wouldn't, we had a great time in Extreme when I think at one point we had way more interns than we had full time. So I'm trying to re-achieve that North Star at some point.
Yeah, so we did, it was something similar. Actually, I was at Hack the North in Waterloo 2 weeks ago with some of the folks here, and the Shopify booth was there, and then I walked around the corner and the Groq booth was there with that set of folks hiring interns. So let's shift a little bit to security. We have our CISO sitting there. And I want to talk a little bit about like, how do you have to think about security in your world, given that, some of it could be just outsourced because you're like, that's what the model's giving me, but there's probably steps in your process which need to be secure as well.
Yeah. I think there's like the following things that we think about from a security perspective. So firstly, we created this framework, and we did this sort of based on discussions that we're having with the US government. It's called Open Bench, right? And it's an eval framework. So first and foremost, I think the industry should self-police and self-regulate itself around basically understanding, what's inside these models, because there's a lot in there, right? And so what's interesting is, from a security perspective, one of the big fears, at least, that the US government puts out, is that, there's like a Manchurian Candidate or Winter Soldier type scenario where it's like the certain set of keywords happen and all of a sudden the model goes berserk. Now, if you understand the technology, kind of can't happen that way, but what could happen is it could embed bad code and a lot of code's being generated. So I think, first of all, evals and big companies like Shopify getting involved there is important, right? I think two, beyond that, when, the code is being generated and what's interesting is we still live in this like linear type thinking around AI. We're working and we're generating code and then we're trying to deploy it. But at any given time, if you update your thinking for any one piece of code that's being generated, why don't you generate 5 of them? And then why don't you have another set of models that are verifying it? And why don't you have another set of models that are building tests around it? And I think once we get into that parallel thinking, I think security will fundamentally change, because it won't be this kind of linear thing of like build something, see what happens, and get caught. It should all be this really highly parallel pipeline that's running, at the same time.
Yeah, it's interesting. I was reading something from Werner Vogel, CTO of Amazon, and he talked about like the order of operations of how you have to think of software. And he's like, security has to be at the beginning.
Yeah.
Right. And then you can start thinking about functionality and performance. And depending on how you order those things, the design of the software changes dramatically.
Well, like there's this new company called Expo, And I don't know if you guys are familiar with it, but it's like the number one hacker on, those the HackerOne and
Yep.
those type of sites, right?
He probably knows this.
Yeah, and it's an AI agent, and it beats all hackers, right? So, and if you think about that, you have to kind of apply that into your own thinking.
Yeah, super interesting. All right, questions from the audience. Yes.
Thank you. Really quick question. So right now with like the Groq chips and how they're kind of working out is they don't have a lot of memory in comparison to like other chips. And
Yep.
especially with these models getting larger and larger, you see them kind of getting sharded or kind of like split across multiple
More and
spots.
more, yeah.
So right now you guys are kind of like that low cost, like the go-to in the industry. As you guys make your chips, what I'd like to assume is larger, the cost is going to get higher. So how do you kind of like, what's like the plan? Like, do you maintain that low cost and like what's
Yeah, no, I think it's a great question, and I think a lot of people, the answer is not obvious, but even though we need more and more chips, right? So there's one place where Groq is not efficient, which is like single user mode. So if you're single user, we'll tell you you should get a GPU because you can deploy a model and run it there. But if you're serving, tens of thousands, hundreds of thousands, or millions of tokens a second, actually having more chips is actually beneficial. And if you do the following math, if you try to build a cluster to do 1 million tokens a second, which is not a lot in today's world, you're going to have the same number of GPUs as LPUs, right? So really, it's only, like in the
And LPUs are just way cheaper than GPUs?
LPUs are way cheaper than GPUs, yeah. And again, like we're way less power because we don't have external HBM. All the things that we were talking about earlier.
Cheaper and run more efficiently.
Exactly, run more efficiently. So when you start looking at scaled clusters, that's where having more chips as part of our architecture actually benefits us.
Cool. More questions?
That's why we don't sell like a single accelerator card to anyone, because it doesn't make sense.
More questions? I got one.
Yep.
When you're thinking about, you talked about the government now becoming a customer. How does that change the way you have to actually either technically build the architecture? Are there more security concerns? Is there a different way that the government likes to use those chips? You have to put those like actual machines in like a government facility? Like, do all these things change?
Yeah, like, first of all, the government workloads, especially if they're related to like national security or something like that, are completely, air gapped from the rest of the world. So you have to build systems, which is, harder in today's world because we're used to everything being fully connected. We can update it 50 times a day if we want to. So you have to create a model for software, and you got to be careful you don't have to fork. You really don't want a team over here building your on-prem air gap solution and over there that, because once that forking happens, you'll never be able to bring it back together. I think that's A. I think B, you have to allow others to basically operate your gear. And I think, I know you've done some experiments early on, but like most of us have lost the DNA when it comes to operating servers and systems. And that's all been pushed into big hyperscalers and all that. So, getting comfortable operating these things is unique. And then, lastly, I think just the connectivity. Most of these, on-prem today, when people say that, it doesn't mean like in the basement of this building. It's like just your own colo somewhere, maybe even sitting beside the hyperscaler, in some Equinix building on Front Street. Right?
You'd be surprised what we have in this building, by the way.
Oh, okay. Maybe you got to give me a tour then.
Yeah, I'll do a tour. All right, more questions? Yeah. Oh.
again round two?
Yeah.
All right, cool. Just a question about like inference in general and like how you see the future of it going. Like you said that the model training part of it eventually is going to kind of taper off as models get really, really good. So a lot of companies are moving towards that sort of like on-device inference or like trying to make things as less cloud as possible. But you guys are going towards that Groq cloud world. So like, where do you guys see fitting into that future of like where things might be going on device or things are also cloud?
Yeah. So the problem I have, and I'm always open to debate and want to understand it. So if you just look at the math that's required to generate like a single token, right? Forget about the technology. It's very expensive math, right? It's like basically, the number of parameters squared times the context length, right? And so if you look at like a typical, CRUD operation from back in the day, you're talking maybe a few hundred or few thousand instructions and clock cycles versus billions and trillions to generate one token. And we're generating thousands of tokens at a time. So inherently the math is very, expensive. And what I struggle with is like, how do you do that, on a device? Because that just requires energy. So I I see people talking about edge inference. I get it conceptually. What I can't get my head around is as models become better and, better models probably mean more parameters, the math is more and more expensive. And so how do you reconcile those two things? And so I believe that there may be some lightweight stuff that happens or some very specific things that get encoded into hardware, but like the heavy reasoning, the more powerful stuff has to happen in the cloud. Or maybe one of you guys will invent something like Jonathan did that makes the math less power intensive or something.
So like this is why my iPhone gets hot.
I mean, your iPhone's not even doing inference, right?
Oh, really? They're not doing. I thought they were doing some things on the phone.
If it's like very, very, very small stuff, not large language model inference.
Yes,
It's doing like traditional machine learning work.
But there are small enough models you can run on your phone.
No, you can do it today, right?
Yeah.
You can even run large. Look, what's interesting is, and I really recommend. There's a really there's 2 or 3 things you do. There's a Karpathy tutorial where he builds like a LLM
from scratch. Yeah, I did that one.
There's that one, and then there's someone that built an LLM that runs in Excel. Right. So you can basically just see how the math works. And, at the end of the day, it's just a lot of matrix multiplication that's happening. Right. So you can run any size of model, even on your phone. You just have to move the weights back and forth between the memory, which in this case may not even be your RAM, just be on your storage on your phone. It'll just take forever to generate a token. So there's nothing special about GPUs or LPUs that it's just that they're much faster at doing the matrix multiplication. There's a lot of efficiencies when they look at the matrix multiplication across sort of the entire system of how it happens in an LLM.
Cool. Okay. Oh, 2. Let me go over here and I'll come back.
Hi, where do you see the future of on-prem AI versus in-cloud AI, specifically with regards to enterprise clients?
Yeah, I think right now on-prem is really big and important because companies fear their data being used by cloud providers to make the models better. Now, it's interesting because these companies, I'm sure even your partners, sign agreements saying we'll never use your data and all that kind of stuff. But I think there's this inherent fear that it will get used either by accident or on purpose. So I think today there's a really big push for that. I do think, what ultimately happens is companies get comfortable like they did moving their big workloads into the cloud, including all, I'm sure all your customer data lives in the cloud, doesn't live on-prem because you guys got comfortable that, whoever, GCP is your big partner is not peeking into your databases and trying to find who your users are and then using that to go sell something else to them. I think we still have to go through that moment. And today, on-prem is big. The other reality is that you'll have to create these loops, kind of going back to your question for a second. We are done. All the data that's available has been consumed, right? And so we have only 2 more sources of data for models to get better. There is data that they generate themselves, synthetic. That's kind of almost endless. And then there's proprietary data, right? So there's all the stuff that just they couldn't have access to. So if you put that together, I think that will push a lot of enterprise on-prem stuff for the next couple of years until there's a comfort that, no one else is taking your data and making their general purpose models better.
So you might have a Groq private cloud offering.
Yeah, we do.
You do? Oh, you already do? Okay.
Yeah. We have, offerings that we can do to people and with storage and all kinds of other stuff as needed.
I'm curious what you think are the coolest use cases that are opened up by Groq's extremely fast inference. Like one example that I saw not too long ago was DMind created this demo of like one of their smaller models. It was like generating a user interface on the fly because it was so fast. So I'm just curious what you think are the coolest use cases that are opened up.
Yeah, I think the 3 that are really popular today are like coding. So the faster you can like tab complete whatever you're doing, that creates a good, better iteration cycle with the developer. So I think that's first.
Yeah, I was going to say, one of the number one reasons we see when we ask folks, of course, everyone wants to adopt these tools. One of the biggest reasons we see when I ask somebody why they don't use it is latency.
Yeah. So that's first. And then I think the second thing is, and we're starting to see this, I don't know if you guys use like say GPT Pro, right? The $200 version.
People personally can buy that. Yes.
Yeah. But you guys don't. You don't.
We don't offer it to everybody.
Oh man, you should have some kind of thing.
I got everybody here is very well compensated. They can buy their own
That's true.
GPT Pro if they would like to.
I'm saying for work. No, but one of the things I find really powerful is, you start today and you have it do something. It takes 10, 12, 13 minutes, right? And it's amazing because I'll give you this example. My son wanted to build a PC, and I used to love building PCs, but I'd probably take like 2 weeks doing the research, like what's the best motherboard and what's the best, SSD and yada, yada, yada. And then I just asked, GPT Pro to do it, 5 Pro, and it came back like 13 minutes later. Probably saved me like a week of evening's research, and it did it in 13 minutes. But now I'm spoiled. I'm like, well, why did I have to wait 13 minutes? Like I kind of wanted that instantaneously. And so I think bringing like deep research down to a very, very small time is going to be quite important for folks as well. And then the last one, which you talked about, is like these interactive UIs, like when people are building things, just real time iterating around it. So I just take that as a version of coding. When you're building something, can you see what it looks like? And everything is just happening, real time in front of you.
Yeah, the speed one reminds me of that Simpsons episode where Homer, they bring a big truck deep fryer, and he goes, "This truck has a huge deep fryer. We can deep fry a cow in 30 seconds." And Homer goes, "30 seconds? I want it now."
Yeah.
It's too slow. And the other thing I'll say on the PC thing is I did the same thing with my kid, but we just went into Canada Computers.
Yeah.
And I said, "Here's my budget." And you'll laugh maybe, but the SSD is a little tiny chip that.
Oh, now, yeah.
figured
Yeah,
it.
yeah, exactly.
Anyway, more questions? Yeah.
Yeah.
Oh, wait, you got over here.
Hey, so I had a question. When it comes to, I saw that you guys recently had a funding round.
Yeah.
So when it comes to the future of I guess a lot of companies shifting from, I guess the cloud to on-prem and developing their own inference chips, how do you see, I guess, Groq's future in that? Because I guess the main issue with inference and compute is, I guess, the bottleneck with memory. And in terms of, I guess, scaling horizontally, adding more ASICs to your data centers, is there going to be a focus on maybe changing, I guess, the architecture, maybe focusing on something more like wafer scale engines, like Cerebras does? I know, which is probably a big competitor with you guys.
Mm-hmm. Yeah, I think, the reason you're typically funded is something's working well. So I
mean, you could talk, but you raised like $750 million, like it's not a small round.
Yeah. And so, look, I think our approach is unique in that we have very low cost chips. We run in commodity hardware. Our systems are all air cooled, which I think is important for data centers. Our cards fit in standard off-the-shelf servers. So you could technically go to Canada Computer or Fry's or whatever it is, basically buy a 4U server and stick our cards in them. So that means basically to scale out, it's, we're kind of more commodity costs there. I think the world, I'll flip it around and I'll say the following thing, which is everyone is fearful that there's like a bubble, right? And usually a bubble is denoted by these crazy prices, which we're seeing now. But also I think more important is like there's a glut of something. And today, I don't think there's a glut of AI compute, right? You'll see that when the AI cost is next to zero, or the latency is next to zero because there's just so much of it. And I think until you see that moment, we're in this growth trajectory that I think very few people can comprehend. It goes back to that example I told you, is that we're just scratching the surface of the things that we're capable of doing. And what the newest models can do, I think very few people can appreciate how much of a game changer that is.
Cool. All right, last one. Yeah, Mike there.
Thank you. This is more of like a general question, not like fully specific to Groq, but with like this mass adoption of AI and these huge data centers popping up, like these large data centers have like a huge strain on the environment also. It's not really like talked about that much, but I just want to know what your thoughts are on that, because like even in the US, we're seeing like a bunch of states like banning the construction of data centers in their towns. And do you think that's like a bottleneck, or like we have to cross that hurdle to like go to the next step of AI? And I just want to know your thoughts on that.
Yeah, I mean, I think that's why in the US, the president put out an executive order basically accelerating data center build. And what the US government did there on federal land, it's even easier to get these things done. And so I do think that there is this tension with communities and energy prices, and also just, maybe whatever pollution may or may not come from these things. But, what I will say is the battle of AI is a battle around intelligence. And it really is the next big frontier, I'd say, between the East and the West, and the East here being China, right? And so, personally, I think for the combination of the West, which is like, say, including Canada, the US, and Europe, winning in AI is paramount, right? Because I think the countries or companies that achieve, what we all want to see in either AGI or ASI or some form of that will basically lead to all kinds of abundance for our society. So I think you need huge support from your federal government to get around it. Yeah, there are energy issues, but energy is going to get consumed one way or the other, right? And if it's not by us, it'll be by the Chinese. And if it's by the Chinese, I think it could have a lot of downstream impacts for us negatively if we don't compete there.
Yeah, I think there's a techno-optimist view, which is like solve AI and solve everything, right? So there's like the Karpathy like went into education. So he's like, I want to solve AI so I can solve education. And there's other people like, I want to solve climate change. Cool. I want to solve AI so I can solve climate change. So similarly, like on the energy side, if we can solve AI, we can probably solve energy as well, because we need super intelligence to solve all these problems. So I kind of take that tech-optimist view is like we have to kind of spend the compute to kind of solve all these amazing problems, like solve cancer, solve climate, like solve education, solve poverty. And that's, that's,
I mean, and Elon talks about this a lot, right? On that, what's the Karstev scale, right?
Yep.
Like basically, it'll force us to adopt that, meaning we should stop thinking about whatever we can consume from the planet, what we can consume from our solar system. And I think that thinking is quite powerful.
cool. I want to thank Sunny for having this conversation with us.
Thanks for having me. Thanks, guys.